one benefit of going on the second day is that I get more time to tweak my slides, but at the same, on the other hand, there are a lot of great presentations that I'm trying to have to live up to. So hopefully you guys are all enjoying the conference as much as I am, so let's go ahead and get started. First I want to do like a quick audience poll, just kind of get you woken up. Show me hands if you're running Solr Cloud in production today. Okay, great, that's good. And then who's running pre-Solr 4 version in production? All right, good, so a lot of Solr experts, all right. And then who that's not running in production actually has like fired it up on their laptop and played with it and had some success. Okay, good. And then personal interest, I'm also the co-author of Solr in Action. So just anybody has bought that book yet or checked it out? Okay, good. Great, I hope you're enjoying it. And so the goals for this talk are, we've been in production about 6 months. We started very early, towards the end of 2012. Like it was the 4.0 branch, I guess, release. And so I want to just kind of help you share the knowledge I gained, kind of things I wish I knew back when I started that we know now. I also want to do sort of the overview of the features you've heard about. This might be a lot of review, especially for those that are in production, but kind of give some context to how I see Zookeeper and distributed indexing and searching, and we use real-time gets and atomic updates. So I want to kind of give you some context behind that. And then also sort of the day in the life, and that section of the talk is actually really boring because a day in the life is actually pretty boring in Solr, which is a good thing. So I come from the Dachis group, and we're flickering again. Maybe it's that image. So let me skip on ahead. Okay, so that previous image was our homepage. Dachis group, we have a platform that does basically business intelligence, deep analytics for brands in social. So it's fairly big data. Don't want to get into my cluster bigger than your cluster, but so we have fairly big data because we are harvesting off these social networks, and then we're trying to do sort of deep analytics. This is a screenshot. For those in the back, it's not important. It's just more of a screenshot of, we have various analytics that most every screen in our app is now powered by something in Solr, facets, that kind of thing. So Solr is really fundamental to our app, which is great, except if it goes down, right, our whole app is like offline, so it can't go down anymore. So here's some highlights to our solution. So as I mentioned, we're in production on 4.2.0. We've upgraded now probably 3 times and are looking forward to the 4.3 upgrade. So right now I have 18 shards with about 33 million docs in each shard. So we're like 620 million docs. And probably each shard is around 25 gigs on disk. And most of that is like small documents, maybe 10 to 15 fields, a lot of tweets, a lot of short comments, that kind of thing. We also do some date-time partitioning. So a lot of our deep analytics queries are kind of on a 30-day window. If you think about it, social, you could probably do like a 3-day window and get most of everything you need. But so we have 30-day windows. So we keep sort of a smaller collection that fits in memory, kind of 100 million for powering some kind of really complex faceting queries and that type of thing. One thing that's unique about, not unique about our data, but really is kind of in this backdrop when we're always designing new features, is that we have this kind of inherent parent-child relationships in our data. So think, like a post of a tweet and then all the retweets that come after it, or a YouTube video and then all the comments over time that come after it. So it's this parent-child. And so I'll get into this a bit, but we actually use the atomic updates support and the real-time get support in Solr 4 extensively. So, and we probably do at least 5 million updates to our existing docs every day. So, and I wanted to mention that because I think it's really significant feature of Solr 4. Once we stop talking about all the replication and sharding, real-time gets and atomic updates are awesome. A little bit about our pipeline and how we populate the index. We're basically do a lot of the, we'll take in a signal, say from Twitter, we have to then detect the language and sentiment and all this various enrichment. And that all happens today in Hadoop. I'll talk about some of our plans down the road to use more of a streaming technology. But so what that ends up meaning is our search index sort of gets indexed in bursts, right? So instead of kind of trickling out millions of documents throughout the day, we send millions of documents, you know, a couple times a day. And we actually, with Solr Cloud, we're reaching like 8,000 docs per second indexing throughput rate with our cluster, which I think is pretty awesome. And you know, we're also constantly deleting, shaving off old docs as well. So there's a lot of change in our index going on every day, which and it's been able to keep up with it. The one thing that may not coincide with a lot of your problems, we definitely have scale at the indexing. Most of our queries are sort of really deeply analytical business intelligence types queries, so I don't have a million users using my site at one time. I wish I did. But so we have a lowish query volume. So when I do replication, it's so that I can sleep at night and not so that I'm trying to like scale out QPS and that kind of thing. It's grown every day, but like I said, that's something that I can't personally say, yeah, we can you know, do 10,000 queries per second in this cluster, because I just haven't had that problem yet. So taking a step back a little bit, when I was thinking about this presentation, I kind of wanted to say, what is it really that I want from a search system? I'm the search guy at Dachis Group, so I'm kind of responsible for this stuff. And you know, I think a lot of these will overlap for what you're looking for. And then how does Solr Cloud stack up right now? The first couple, scalability, high availability, I won't go too much into those. I mean, I think those are all pretty straightforward. It needs to basically scale with our capacity. But one thing I think I like to think about when talking about scalability in Solr is that, yes, sharding allows you to scale out and horizontal. And I think Stefan said it great yesterday. You know, sharding's a magic sauce of web scale. And to an extent, I really agree with that. But at the same time, don't starve your individual Solr cores of resources. So I think there's this sort of dimension of scale up still in Solr. It's not like I have a decent sized Hadoop cluster where I really can just throw JBOD and low-end hardware and just beat them up, and if they die, who cares? That's what Hadoop does. Solr is not quite that regard. I think it's you need fast disks, you need things like RAID, and you need a lot of RAM. So I think especially if you're just starting out with Solr Cloud, don't come into this thinking I can just shard my way out of all scalability problems. I think there is a scale up dimension. When I started out, we kind of went with the wide, lots of shards. Like you saw, I have 18 with only 30 million docs in each. But I have a little bit, like too little of RAM on each node, and that's caused me problems. So think about maybe even have a little bit bigger shards, more RAM. So the kind of the bottom three is what I really want to talk about on this slide. Let's first talk about consistency. Everybody has heard of CAP theorem and all that? Okay, so the current thinking on that is the P part, network partitions are a given. They're going to happen. So you really get to kind of have this balance between consistency and write availability, right? And Solr Cloud favors consistency. Right? And to me, that's the right approach, because I think in the Solr in Action book, I use the example of, think of a real estate portal where maybe one replica is serving this hot property and another is not. I mean, that's something you don't want. So I think the concepts of eventual consistency like you get in a Cassandra definitely don't work in search in my mind. And so what you're going to see with Solr is when you send an update, you're not going to be able to say, you know, update this, and I don't care when it's kind of like replicated, right? It's when an update is sent in, it has to be accepted by all active replicas and on durable storage before Solr will say, yes, that update worked, okay? So that's Solr favoring consistency, and I think Mark Miller, his talk later, he'll probably get more into that if you want more details. But the other thing, these bottom two, simplicity and elasticity. I put work in progress there because I think Solr does a pretty good job at it, but at the same time, those are kind of the areas where like there's a lot of work going on. And from when we started out in 4.0 back in November to now, I mean, it's just been amazing improvement, you know, and Solr 4.3 is starting to come out. So, but hopefully some of the things I talk about today will help put you at ease with the simplicity. But at the same time, Solr Cloud still kind of has some things, especially like in troubleshooting when things go wrong. If any of you watch the mailing list, some of the questions now are not so cut and dry when problems are happening in the replication and all. So, and I actually had one of those myself that Mark and I are kind of still scratching our head on. Elasticity. So that there is the idea there is, well, we planned for the system to be X, and then the growth kind of was bigger than we thought. So now let's add nodes. When we're talking queries per second, it actually is very elastic. You can add a new replica. If I bring up a new node, Zookeeper will say, great, here's your index, and you know that will come from the leader, and then it can start serving queries. So in terms of scaling queries per second, that kind of thing, I think Solr does a great job and is in good shape. Incoming in Solr 4.3 up to this point, though, if your shard got too big, right, basically you were kind of faced with the proposition of my shards are too big, I have to manually rebuild a new cluster and do the splitting and break it into smaller pieces and re-index. I used to not think, and this is, if you look at the Apache Eurocon panel I was on, I was like, you just re-index. But now that we have 600 million docs, it's just, it's a lot harder problem than it was 300 million docs ago. So this ability to take a large shard and split it into two smaller ones, it's coming in 4.3, which is soon, I think is a great leap forward for Solr and being able to be more elastic. Okay, so this is the Solr Cloud that I cooked up on Wordle when doing the slides. That's kind of when I started with this. That confusion there is really what I was like, wow. So does this slide speak to anybody when you say, you know, because there's actually a lot of density in a lot of these concepts. And you think maybe I get, you know, I definitely get NoSQL, but in the term of Solr, maybe not. So what I want to do is kind of just run through some of the things from that word cloud about Solr Cloud so that, you know, you can kind of see what we learned and what I think is important. Give a little context. So the first thing is, and I think Zookeeper, there's some, and I think it's getting better, but there's some kind of tension around Zookeeper, like it overcomplicates Solr Cloud, and why is it there, and it's this cluster off to the side, and all this kind of stuff. So to me, this is really, if you knew these 5 things about Zookeeper, you're good, right? And the first one is, if you're going to do this in production, it has to be split off from Solr. Solr allows you to just bring up Zookeeper, but that's really for eval purposes, so that they didn't have to send you off to some Zookeeper docs to actually like go set this up before, because no one would want to try Solr, right? Solr Cloud if they had to go set up Zookeeper first. But if you're going to do it in production, you have to have at least 3 nodes, because that's how Zookeeper works, or at least needs to be an odd number of nodes so it can establish quorum. And as quickly as possible, get off of the embedded Zookeeper. The second thing is, and this is kind of more in how Zookeeper works, but once I got this, Zookeeper made all the sense in the world to me. Solr, one of your cores, will contact Zookeeper and create what's called a Z node. That's its like folder or directory that Zookeeper works off of. It's a hierarchical, like a file system, but they call them Z nodes. And the key is that Z nodes can be ephemeral. So Solr can contact Zookeeper and say, this is me, I'm up, but it's an ephemeral node. And if that Solr crashes, the Zookeeper infrastructure will make that ephemeral node go away. And that's exactly how Zookeeper knows your node is offline, right? The ephemeral node went away because Solr stopped basically saying, yes, I'm here. That's very key in how all this works. The second thing is that Zookeeper, one of the things it does very well is it allows a client, in this case Solr, to say, I want to watch and know about when a Z node changes, okay? And so what Zookeeper does says, okay, great. And when a Z node changes, it tells them all. And Zookeeper does this in very massive clusters at Yahoo and that kind of thing. So the example there is Solr can cache the cluster state. It knows what leaders and replicas and all that stuff it has. And it can cache that internally. But it can also say, if that changes, such as a replica goes offline, I need to know about it. So I stop routing queries and things. That all happens in Zookeeper. So once I kind of got that all Zookeeper's doing is one is allowing nodes to attach to it in an ephemeral fashion, and that it pushes out changes on Z nodes, it was like, that's easy. The next thing is, and this is where I think kind of the tension around Zookeeper, why is it in Solr, right? To me, it's because Zookeeper, you guys probably remember some of at least the older engineers, there was that whole design patterns book, Gang of Four. Well, Zookeeper is like the designs pattern book in software for distributed systems. And what it does is it has recipes for things that come up when you're building a distributed system, like leader election, right? Zookeeper says, we've seen this problem so many times, this is how you do it. And it's this recipe. And Solr Cloud builds on that, right? And rather than going out and reinvent the wheel, they said, we're going to use this because it's tried and true and it's been used in massive, massive clusters. So in Solr Cloud, Zookeeper provides three basic things. Centralized configuration, so that's great, and I'll talk about how we do that. Leader election and cluster state notifications. That's it. Second. Another thing that comes up inevitably at the onset of as a Solr Cloud, and it's not as much of a problem with the shard splitting as much, but you still have to plan, right? I mean, you still can't just say, I'm going to have 20 shards without thinking it through a little bit. So there's actually not an equation you can just kind of plug in some numbers and spit out, you need 16 shards, right? These are some of the things that factored into my decision of how many shards. Probably the biggest one for me was expected growth, and I think that's not as important now because you can split shards, but I think it's also important to say shard splitting is not going to be cheap. Like you can't just turn around and shard split every 10 minutes, you know what I mean? It's going to be still a kind of a heavy duty process, almost like a merge, an optimize. So you want to do some planning. So these, again, let's take like number of documents and work through a scenario. So if you have 100 million documents and you need, or you have a query that matches 100 million docs, I don't know how many documents you have, or say it even matches 10 million documents. If you have one shard, when you sort that sucker, other than even if you sort it by date, but say we want to sort it by date, you have to sort all 10 million just to get that first page, right? I mean, that's basic search. So think about it. If I then took my 10 million docs and put them on 10 shards, so now I have 10 different servers doing that sort of a million, okay? So that's a lot more parallelization. It's going to scale a lot better. Obviously, when that comes back, and I have a slide that kind of talks about this, you have to now take 10 sorted result sets and merge them down into one. So there's an additional overhead, but it's a heck of a lot easier to merge sort, you know, say your page size is 10, merge sort 100 documents than it is to sort a million. Right? And so that's kind of where the number of documents come in. And I guess I should have said number of documents, you know, matching queries, right? Because it really doesn't matter if you have a billion documents, but your queries only match 100 every time. I mean, right? Who cares? The other thing, and then this kind of gets into some of the problems that we're looking at, is the update frequency. As I kind of started out, our docs are changing a lot, right? And so I want to distribute some of that load around so that each node can actually, you know, not have to change as much, right? So kind of distributing the updates and that kind of stuff in an index that changes frequently. Another, when I was starting out, is this whole index memory management, right? Very confusing. And this probably isn't as much Solr Cloud as it is just raw Solr, but I think it comes into anything you're going to be faced with when you're setting this up. If you've not read this blog I give a link to, I think I highly recommend it. So one of the committers on Lucene is Yu Schindler, and his advice is if you're running on a 64-bit platform, go with mmap directory, okay? And what that allows us to do, actually, my max heap size is 4 gigs, right? And remember, I use all the filters and facets and all the kind of things that Solr does. But what I do is I keep my heap small, and we'll talk about what that entails, and it frees up RAM actually for this mmap directory thing. I'm not an OS caching expert, but in a nutshell what it does is it allows Lucene to basically load your whole index into virtual memory, okay? The whole thing. Or at least the things that need to actually be searched, not stored fields. So it's not just the size on disk. It's a little more complicated than that. But it basically loads your OS into virtual memory. Now, as much of that virtual memory that can actually be in RAM, the better. And that's how you're going to get your read performance out of this thing. So essentially what it does is it says, let's keep most of the memory to load this index into our memory mapped I/O, right? Really helps performance. I've seen some chatter on the mailing list that some people don't do this and have success, because the other is the NIOFS directory and that kind of thing. I won't even talk about it if you're still on like 32-bit Windows. But what we've had to do here is because I have a small heap, and I want to get that actually a little bit bigger. But me personally, I hate garbage collection problems. I mean, is there anybody that just really loves it when they get a production report that their garbage collector's not working right? Okay, so one hand went up. I just want to make that note. So, and that can be fun if it's not in production. So what I've had to do is say, okay, my heap is small, and most of that's going to go to like faceting and that sort of thing, and sorting. So my caches are like really small. This is my filter cache, and I set a max size of 50, and then I auto warm half of them. And I'm actually using, this is a new feature in Solr 4, is the least frequently used cache. So I kind of use the, made sense that I was like, you know, if there's this one query that runs every 10 minutes that basically, or you know, every couple of minutes, but it's from one person, that LRU kind of knowledge of the least recently used didn't make sense to me. I want basically my most popular filters to basically not get evicted. That's what the LFU cache does. And so that's pretty small. Like, I think out of the box, the example comes with like 512 or something. It comes maybe 250. That's pretty small, so my eviction count is really up. But what this does is it actually spreads your garbage collection penalty over time, because you're constantly evicting things out of the cache, right? Because what happens when you open a new searcher, right? Everything cached is gone and has to be rebuilt. So that basically says, here's a garbage collector, here's a lot of objects that need to be GC'd, right? So it ends up causing a lot more work on the GC. Having tighter caches and a smaller heap for us makes it so that we're basically spreading that GC penalty. We're getting the read performance from here, not from our caches, right? Now, granted, that's kind of, excuse me, black art of Solr. This is what works for us, you know. So kind of take it as a grain of salt there. Let's now talk about this leader, because I know there's been a lot of confusion originally, and I had a lot of confusion. Well, what is this leader really? So the leader is not a master. And I think that's pretty straightforward. The leader actually is a replica, so it can handle queries just like other replicas. But much like a team lead on a software development team, right, the leader writes code, all that stuff, but also has to kind of do that weekly report and whatever, right? So that's kind of what the leader is. So one of the things it does is the leader actually takes the update requests for the shard and then distributes those to the rest of the replicas, okay? The leader is also responsible for this kind of special magic version field, which is used to power the atomic updates using optimistic locking. Talk about that in a second. And then this is pretty important. Say you add a new document, the leader accepts it, and it has 10 other replicas to actually go out and push that update to. It does that in parallel, right? And then it waits for all those to accept before it says, okay, yes, I've accepted that update, okay? So that's really what the leader does. Let's kind of break it down a little bit in this slide. I apologize, font size for those in the back. So this is kind of distributed indexing 101. We use the CloudSolrServer, which is in SolrJ, and that's a smart client. It's not as smart as it can be, and I've kind of talked to the guys on the mailing list, and there's some plans around that. But basically what it does, why it's smart, is because it actually gets the cluster state from Zookeeper. And for indexing, it needs to know the URLs of the leaders, right? Because with Solr Cloud, you can actually send an update, an index request, to a replica, but then the replica says, well, I don't do that, right? And it has to forward it to the right leader, right? Well, so this CloudSolrServer kind of right now shortcuts that a little bit and sends it to the leaders. But the kicker is that it doesn't send it to the right leader, not necessarily, right? So the plan down the road is to be able to actually have him do the document routing here so it can go to the right leader right off the bat. But it doesn't do that right now, but it's kind of in the works. So it sends to the leader, and this leader, first thing it has to do is has to hash the document ID. Well, I'm not going to talk too much about custom hashing, so this is how it works out of the box. So that document ID gets hashed, and every shard has a hash range that it covers. Excuse me. So this shard decides that shard 2 should actually have this document, so it forwards to that leader. At that point, the leader now is responsible for indexing this document, and one of the things it does, as I mentioned, is it sets the version. Okay? And that version is now used for all the optimistic locking in Solr and that kind of thing. It also writes to this thing called the update log. And the update log is like a database write-ahead log, a wall log. And so it basically ensures that all accepted updates are on durable storage. Okay? So that when it tells the client, yep, I got your update, you know it's on durable storage somewhere. Then it forwards that update to all the replicas and makes sure they respond. And again, it does that in parallel. So one of the things that we found with this update log is actually they can get big, especially because back in the old Solr days, we used to have these huge auto commit windows because we didn't want to affect our query performance by having these kind of behind the scenes commits opening new searchers. But the kicker now is that in Solr 4 you can say open searcher false. Really applies to auto commits, as you can see there in the XML. So what that does is it basically snapshots my update log and commits the documents, but it doesn't affect the query side, right? It keeps the old searcher open. Now, you might think, well, why would I want to do that? I want those documents visible, right? And this is not near real-time search view. This is like if I'm doing a batch of 1 million new docs indexed, I use this. I have a short auto-commit window of like 10,000, but I don't open searcher until all 1 million are indexed. Because to me, having half of 1 million documents visible, within a minute or whatever, it's not as important for us. So if you need that like really quick visibility, then there's the near real-time search. But for us, this keeps the update log short, but also allows you to kind of, I guess, balance your when you open searchers and when you don't affect the query side. Okay, I'm running low on time. So distributed search. How this works is essentially, and I think the key point here is that we're actually still using our SolrJ 3.6 client to talk to our cloud cluster. And that's great, and you should know that. Like, you don't have to change your apps just to move up, your query side apps just to move up. You could use the CloudSolrServer because, again, he's smart and knows all the active nodes here. The key is about distributed search, and this is not new to Solr 4, but I just want to make sure we're clear on it, is that it's kind of a two-phase process. The one that accepts the query first sends it to all the replicas. It could be himself as well, because we need to hit both shards in this query, shard 1 and shard 2. And then it does that merge sort of the results, and then it kind of goes back to the shards and says, well, give me the rest of the fields. Because in that first request, when it executes a query, it only gets IDs and the score and the sort fields, right? And then it goes back for all the other fields. So it's this two-phase process. Okay, so I talked a little bit about atomic updates. This really saved us. So I'll give you the use case, and we'll probably run out of time, but I can talk to anybody after this. So our use case is basically companies really want to know kind of the performance of things they're doing. Like maybe they pay a celebrity to tweet something out about their brand, and they want to see all the activity over time about that, right? So if we post something on Monday, you know, how much activity is still around on Thursday, that kind of stuff. So we have this kind of parent-child relationship, and our initial reaction was great. Solr does joins, and they're designed for sort of parent-child relationships. And the problem, though, is, of course, joins don't work in distributed mode, right? They actually can work if you do custom sharding, but you'll have to keep everything that needs to be joined in the same shard. We don't do that. So along comes Solr 4 and the atomic updates and real-time get. And so briefly what we do is we, in our pipeline, in our analytics pipeline in Pig and Hadoop, we calculate sort of all these daily volume, daily activity metrics, and then we stamp them into these documents using atomic updates. What that does is basically allows us to avoid joins, which we didn't think would scale anyway. So we went with this approach. They're great. Behind the scenes, when you do an update, it's a full delete and reindex. So that implies actually that you have to store all your fields, right? So every field in your doc has to be stored, because what's going to happen is Solr will delete it, take the update, merge it with all the existing stored fields, and recreate a new document and index that, right? So that's something that you should be aware of. It worked great for us, and we use them heavily. So let me quickly run through some lessons learned and try to wrap up on time. When I started out, I had like 300 million docs, and I knew I was going to quickly be a lot more than that. And so I didn't know, will this work? And the answer is definitely, it is working, right? And this is more a testament to technology. Also, my counterpart works on the more of the front-end query side, is awesome. But the Dachis group search team is 2 people, me and 1 other person. Okay, and so we do all the DevOps. We do basically everything. One thing we found is our planning. When we laid this thing out, we had an idea of what queries we needed, and the queries we're executing today, I mean, we couldn't even envision. Like, search became addicting, and now like every product that we build has some search component to it. Like, it's just grown. Our product managers are, you know, they actually use Solr to do a lot of kind of ad hoc analysis and that kind of thing. So really, when you're doing planning, you're probably not going to get it right anyway. So it goes back to the whole agile thing. Like, you know, get close, but realize it's probably going to be a lot more complex very quickly if it takes off. Buy more RAM. I can't stress that enough, that, you know, most of all the problems we've had with Solr Cloud has been we don't have enough RAM on our systems. And that just causes problems. So this wasn't apparent to me, but now that I think about it, I should have caught this one, was Solr Cloud's great. The replication node goes down. You don't have to worry about it. But what happens if you lose the whole data center? You still have to have disaster recovery, right? And so the good old Solr replication has backup support. That's the safe way to back up your index. So definitely use that, but build that into your planning up front, that you really want to also have a disaster recovery if you lose a data center. those other two are self-explanatory. I can talk to them. Another thing that we got was, and we use dynamic fields heavily. Our schema has evolved so much. Like I did a lot of upfront data modeling and thinking. I got it completely wrong. I mean, we like have really churned through our schema over the last 6 months. 10 fields, but that's on top of docs that only have like 20 fields. So I mean, like I've had to churn half my index design. And then, oh, this is sort of interesting. We have to have a staging environment to go tinker around in, right? So I size my staging shards. I size the size of my staging cluster so that the actual shard size is the same as my production, but I have way fewer nodes, right? And that allows me to kind of do more of an apples to apples, because I didn't want a staging environment that had like 2 million docs in the index, you know, where I'm trying, and then I'm pushing code out to has, you know, 10 times that. So, and then lastly, this one kind of really stuck with me is that when we started out, we were kind of like just use Solr kind of as a box. It's really designed to be extended and have plugins and things. So we take full advantage of value sources. We probably have like 3 or 4 different custom value sources, do all kinds of funky things behind the scenes. There's also this concept of post filtering. This is a custom function that we have, and it basically says, you know, filter if you're an employee of, that's actually Red Bull in our index. If you're a Red Bull employee, but this is the kicker here, the cost. Solr says, okay, you're telling me this filter is expensive. I'm going to list it after I've run all other filters so that when it hits this expensive filter, it does it last, so it's looking at a lot less documents. So really cool feature. Check it out if you're doing anything with filtering. Okay, I didn't get to all the rest of my slides, but does anybody know a system administrator that dresses like that? That's why I bought that image. I was like, there's no way. So this is kind of like, you know, they're going to post the slides, but these are some of the things just I've learned, kind of DevOps-y stuff, keep in the back of your mind, you know, some of the things we monitor for. This is straight from Mark. Kill your process if you OOM, because it can wreak havoc in a Solr Cloud cluster. And then what I'll do is go ahead and open up for questions, but after Hillary Mason is, I had to have a lolcat slide. So if you do find yourself in that situation, buy more RAM. So thank you, and I'll take questions, but I don't want to eat too much into the next person's time. So are we okay on time? Thanks, everybody. Oh, yeah. Yeah.